Hello students, this is Deepti Yellanki and I welcome you to one more session of Engineering Hydrology. This is lecture 2 of module 1. In last session we have seen hydrology and what is hydrological cycle. We have also seen some definitions of some terminologies related to it. So today we will see what is global water budget and India's water budget. Before that, we should first understand what is catchment area. Coming to catchment area, you have seen in your place, if you just imagine, there is a pond or some low-lying area. So all the water from surrounding highlands or high-lying areas all come and collect in that particular stream or pond or whatever water body is there, which is low-lying. So this is common in any area. Every area will be having its own catchment area where whenever precipitation occurs, water flows from all the mountains and hills into that particular catchment area. You can see this clearly in this figure. You can see the arrows, the tributaries are there which join from all the areas, all the high-lying places and come and join one common stream. Yes, so this low-lying area is called as a catchment area. Okay, so catchment area it's a terminology. It is also used for your household purpose also. If you have a rooftop and whenever precipitation occurs, this water is collected in a conveyance system and then it is again connected to a distribution storage system. Yes, this is a storage tank. From here it is distributed. Like this water could be used for washing purpose or any other sanitary purpose and all. So at least this water is made into some use. Okay, so this is about catchment area. So if there are two or more catchment areas, what is the thing, how it is separated? Let's see. See, for example, this is a catchment area, yes, and this is one more catchment area. So this, if we see this segment 2, so there are two highlands and this is a lowland in between it. So all the water from here to here, everything is collected in this, whatever precipitation occurs on this part, this side of the hill. Will this side of the hill precipitation participate in this catchment area? No, it will not. It will go into this catchment area. So there is a clear line demarcating or separating two catchment areas. This line is called as a ridge or a divide. Okay, and this catchment area is also called as watershed. So this orange part is watershed and this line which you can see, this is a ridge or a divide. Next, let's see what is residence time. So initially in the previous lecture we have seen what is hydrological cycle. Yes, hydrologic cycle. So when a water molecule it passes through a particular phase of hydrologic cycle, complete hydrologic cycle. So what time it takes? That is residence time. Okay, residence time is the average time taken by water molecule to pass through a particular phase of hydrologic cycle. So the formula you can see here, volume of water in a particular phase by average flow rate in that phase. So the units for this would be anything, days, months, whatever it is. Okay, time units only. Now coming to global water balance. What is water balance or what is water budget? Budget is nothing but how much you are getting and how much is going out. Yes, at your houses also you have this budget. What is your income and what is your expenditure? How much you are getting and how much you are spending. So this is what we'll be seeing. What we are getting, that means inflow, that means your precipitation, that means your rainfall. Yes, and what is the outflow, what is your expenditure, what is going out is your it could be your runoff, it could be your evaporation, it could be your what do you call groundwater seepage. Yes, all these things are your outflow. Okay, so complete budget when you prepare for both the things, like how much is inflow, how much is outflow. Yes, this is called as water budget. Okay, the concept is behind this, why do you make this budget? Do you know? This is basically to understand in a particular area how much water is coming in and how much is going out. So how much is the net storage of that area? So if it is good, the people like hydrological engineers and all, they plan for water resources sustainability management, how well it is managed, environmental planning and all. Yes, all these things are done on basis of this data only. Okay, how much water storage is there in that area, particular area. Yes. So coming to global water balance, what is this? In earth, in complete, in the whole world, so in this earth, what happens? There is 1386 million cubic kilometers of water available in complete earth, everything including oceans, land, everything included, it is this much. But 96.5% of water is in oceans. 3/4 part of earth is oceans, right? So that much part is in ocean. Then coming to land, there is again some part in ocean. Anyways, the ocean water you cannot drink, that is non-drinkable. Again coming to land also, there is some part of water which you cannot reach, that is deep infiltrated water, which goes under the hard strata and gets trapped under it. It's sometimes difficult to tap it back. So this is also, there's 1% of water which is tapped under land, which you cannot, or on land also you cannot drink it. Okay, then you have fresh water of only 2.5% of total water available. This is your 35 million cubic kilometers of water which is available. Okay, very good. This is also not less. Yes. Now again, what is happening? If you see, 24.4 million cubic kilometers is in frozen state. This much water is in frozen state, which again you cannot drink. Now what is left over? Only 10.6 million cubic kilometers of fresh water is available in liquid form, readily available. So now you understand why water is so precious. Yes, water is there, no doubt. But can you drink it? Can you have it? Can you use it? No, saline water, you cannot use it. Yes, deep infiltrated water, you cannot use it. You cannot reach the frozen water. So what is available? We have to see that it is conserved well. Okay. In this slide you can see the annual water balance, global annual water balance. That means the area, the ocean area and the land area. So obviously when the ocean area is more, precipitation is also more on the ocean area than land. You can see how much it is, 4,58,000 on ocean and 1,19,000 on land. Yes, then there is again evaporation data, runoff to the oceans. There will be no runoff because water will run off into the ocean. So that is the runoff is from land. So obviously under land it is given how much from rivers, how much from ground, and total runoff, everything it is given here. So this is the annual water balance. Next, estimated world water quantities. So you can see how much water is there in ocean, groundwater, soil moisture, polar ice. Yes, all these things we have done, but this is more into detail. Yes, how much area is there, volume is there, percentage of total water, excuse me, and percentage of fresh water. So just go through this. Next, coming to water budget equation. Now what is this? We have already discussed what is water balance. When water, there is precipitation, there is inflow of water. Yes, there's again outflow when there is runoff or other things like evaporation, seepage losses and all. Yes, all these come under outflow. So when total inflow of water minus outflow of water, you will get the net storage. That is your change in storage mass of water, that is delta S. Yes, so that is the formula given here. For a catchment area at any time delta T, mass of inflow minus mass of outflow equal to change in storage mass of water, that is your delta S. If density of inflow, outflow and storage of water is constant. Coming to volume, now you are giving the same formula in terms of volume of inflow minus volume of outflow equals to change in storage of volume of water. So this is the basic equation. Coming to storage equation, storage in catchment. So how many types of things are there? Inflow and outflow. What it is? Inflow, you have basically the positive thing is what is coming in is your precipitation, rainfall, hail, everything comes under it. We have seen what precipitation is. So precipitation is your inflow. So everything else will be deducted. That means outflow. What are the outflow? Evaporation, groundwater outflow or from catchment. Then you have your surface runoff. Then you have your transpiration. Yes, all these things you have to deduct from the precipitation. This will give you your delta S. Okay. So this is clear, I think. Coming to India's water budget, you can see how rainfall is distributed in India. Yes, you can see this picture here. There's an India map given and color denotation is given. Like blue color is around 4,000 to 11,000 of rainfall. Yes, millimeter of rainfall. So that is more in eastern part and southwestern part, coastal area. Yes, you can see this is all arid place. Gujarat and Rajasthan, it's very dry, which is orange in color. Rainfall is there but very less. Okay, so this is about your annual rainfall which is given in this. So with this you get your rainfall. Then again the same outflow is your evaporation, seepage. When you deduct those you get the net storage. So this is about India's water budget. Okay, so basically why we do this? For management of water resources. Yes, you have to understand what rivers are there, what lakes are there in and around, and how it could act like a catchment area. Like you could also use some natural barriers. You can see here some hills and mountains for storage of water, and simply by construction of a dam here you could store lot of water. Yes, so for this purpose we have to know how much water is inflow is there, outflow is there, what is the storage of that area, catchment area. Then we should understand water budget, water balance. Yes, so this is all about water budget in India and the global. Thank you very much for watching, and if you have any doubts please do ask.